Good morning to everybody, or whenever you are listening to this session today. I'm very glad and pleased to be here. And essentially, we're going to be addressing five main topics. Uh, Talking about the brave new world that we have ahead and the challenges around it, as well introducing new concepts that are really important since we got that disruption in 2020 with dynamic learning. So we close the loop and go fully to explainability and machine learning integration. That's why we are speaking about solving AI and machine learning at scale. Well, we know that COVID accelerated trends which we knew they were coming. We were already preparing ourselves to explore more about alternative data sources. The consumers, they were already going towards digital transactions, a bigger expenditure online. And we also knew that the companies overall, they were investing in machine learning. However, over the past couple of years, so to speak, we saw that those numbers, they really accelerated. So now we are seeing things like 98% of lenders, they need to deal with alternative data sources, or they are seeking alternative data sources. The investments in machine learning and AI, they have increased by almost 30%. As well, the impact in provisioned capital in banks and financial institutions, they went over $1 trillion. But yet, more than half of the data science projects, they are not fully deployed. So we have this brave new world ahead of us. We have more investment than ever in AI and machine learning. However, this research from Gartner that came up this calendar year, so to 2021, it's already showing that more than half of them, they don't get deployed. So it means that this money, it's going somewhere and it's not generating ROI. And the point is, okay, what are the reasons, or what are the challenges that institutions in general they are facing, so they cannot get their models fully deployed? Because it means that, well, maybe they are developing it, they are finalizing the development of the models, but they cannot get in there. They cannot really get the best out of it. And yes, actually, we have mapped not only from this report, but also from the experience that we had with our customers. There are four main challenges around the deployment and using machine learning at the scale. So the first one, it's about the development itself. So yes, it's yet very difficult for some organizations to get data, to handle the volume of that data and make their IT departments available to extract and to load whatever database that we are talking about. Even if this may sound like a node discussion around machine learning and AI, this is still a burden. Then let's say you get over that development component, you get the data to develop, you still need to deploy it. And here we have a new order of challenge, because sometimes it can be very complicated to get the models into deployment. There is a lack of machine learning operationalization and a scalable methodology. So here you yet have another point. But even if you get in there, there is the need of explainability. Well, we have been dealing over the past 3-4 decades with traditional statistical models like linear regressions, logistic regressions, and they are quite straightforward to understand the outcomes. Well, when it comes to machine learning, there was that myth of machine learning being a black box, which it's not necessarily true. And there is a way that you can get your models explained in the same way that we do with the traditional models. So yes, you need to explain and also to maintain such models. So if we look to these four main challenges, they are not necessarily new, but let's say they got bigger with the rise of machine learning and the need to get AI at the scale. For each one of these steps, we have the solutions, and we have found the ways to support our clients in order to get over them. So we are thinking and we are speaking about the platforms that allows you to develop, to deploy your models, to get that explainability done, and also the maintenance. When it comes to the development component, we have an enabler that we call it Power Curve Analytics. That it's a baseline platform that you can attach to Power Curve, that it's called Ascend, where you have, depending on the market that you are in, the possibility to explore the full set of bureau data that it's available, the possibility to include your own data whenever you want. And together with it, you get the productivity toolbox that has been developed with the standards for model development and testing. You get the full automation of the development process that you can have in no time, something that was used to be complicated. And now with the press of just a few buttons, you can have a first version of your model done. And of course, they are templatized in a way that you can get into action pretty quick, but also if you need to get any kind of customization to attend a specific needs, they are fully available for you to change them whenever they are required. But not only that, so we need to comply with several regulations. We have the European bank authorities with the new set of regulations coming up. And we have already the risk models where we can ensure the validation, the monitoring, and the reporting components automated in a way that you don't need, to worry about if it's going to have a human errors, if you are going to have a not automated process, because everything now can be automated. So we have the full wheel of the development process. So this is one of the challenges, and this is one of the ways that we can overcome them. The other, it's related to the deployment. So we can see from the left-hand side that this is a traditional development cycle. So you need to get several teams involved into it. You need to get over several steps in order to get a model into production, even if we were talking about traditional models. So it doesn't matter. They might be really complicated to get into, but this is the best. Now, we have seen some institutions, they may take 6 months, maybe a year to deploy a model. And I'm not exaggerating. This is a reality in some cases. But even if you are talking about only 3 months, this is yet a lot amount of time, because your model, especially when you have shifts into the economic outlook like we had the last year, the models, they need to not only get into production quicker than ever, but also they need to get updated quicker than ever. So here we have the Power Curve Analytics Suite, where you have the platform that I was mentioning earlier, where you can easily export the model out of it and deploy it into the PCSM, into Power Curve Strategy Management. And you can do this in just a few clicks. So the deployment challenge that we used to have, we don't have it anymore. And one may think, okay, I can develop, I can deploy, but then I need to explain the machine learning models. And this has been a blocker for its utilization. Because, if I cannot have the full clarity on why the model gave us a specific outcome, I cannot use them into production. Well, and it's actually something that it's also going to be into the past. Because once we have the development and the deployment integrated in a way that it's easy to be implemented, and there is no need to re-platform, We are moving out of an environment where we have silos. So you have a place where you develop your model, you have a place where you get your models into deployment, and you have your decisioning environment. We are putting everything together in a way that you have integration, you have the feedback of your data, and then we can think ahead, we can think into the future, and why not provide a dynamic environment for that model update? And I will get there in a moment. But before that, I would like just to give a little bit more of insights around the explainability. And this actually, it's quite important. Last year, in January 2020, we got a report from the European Bank Authority where for the very first time, they started to address explainability of machine learning models as elements of trust. And it was very interesting because we had this diagram coming out of that report. And here we can see some keywords that actually they are very important. So you can see that the bank authority, it's already accepting more than they were before the machine learning component, but you need to think about the ethics of your model. You need to care about the explainability and its interpretability, and around the fairness and its bias, and the elements that that we saw earlier. So there is more openness around this topic. And why this is possible now? Well, the main reason machine learning model explainability, it's not mainstream yet, it's because many people, they don't know that it's possible to explain. So again, if we look to the left-hand side, we can say that, well, people think that machine learning, it's really complicated and can be something very confusing to see if you just get a technical perspective, which is true. I mean, even myself as a data scientist, I look at this decision-based tree algorithm over here, and I cannot understand anything. So they could be really complicated. However, there is a methodology that we have adopted and developed that you can really make the machine learning models look like the traditional scorecards. So this is an actual result that we got from our project, where you can see for a single inquiry that we had in a single application, you have all the variables over here, and there is a specific and exact contribution of every single attribute for the model outcome. So this is quite reasonable because you can get then, well, eventually, Mr. Client, you get this model outcome because of the biggest contribution or the positive contribution of this attribute over here, and a set of negative contributions from these attributes on that side. And then you can get into a level of explainability in no time. And this all can be fully automated. And yet you have the maintenance component. The majority of the EMEA institutions, they lack validation resources, and especially automation. So these are some facts and figures from a report from Deloitte, called it Model Risk Management Survey from March 2021. And we can see that almost 60% of the institutions, they lack sufficient resources for model validation. There is also the lack of specific model validation standards for 61%, and the lack of automated process for the majority of institutions, where especially if they are smaller or medium-sized institutions, this number could go over that. And yet, even into the large institutions, more than half, they don't have automated process for the maintenance of the models and the validation process in general. Now, this is something that we can also address. And then on that suite that I was mentioning, we can get every single step of the process automated. And this is something that it's already available as today. It's something that we can really address. Now, could we think about the future? Of course, and we should, and we are thinking about the future. There is a very specific component that we want to introduce that it's regarding dynamic learning. And out of it, what we can think about, it's the following. Remember back in 1996, when we get the chess master Kasparov challenged by the IBM Deep Blue. Well, on that time, and we are speaking here, well, more than 20 years ago, we were talking about not necessarily the first time, but we were talking about computers that they could learn by themselves and they could improve in automated way. Something that 20 years ago was something that was in the very beginning. Nowadays, it's becoming a reality. But the point is, we need to be able to get algorithms and to have an environment that can feedback itself, so we can receive this feedback from the data, from the decisions that they have been taken, and make the model update itself, react to the changes into the environment, and then we get the automated process. Now, our challenge then would be get models learning faster than a chicken. And why is that? We are speaking about reinforcement learning models. So there are actually models that they will react and learn from the environment changes. And well, I find this video brilliant because here we can see that the chicken, it's pecking the pink disc in order to get food. You can see that the trainers, they started to increase and change the environment, adding new discs. And by reinforcement or a positive reward, that it's the food, whenever the chicken pecks the pink circle, it gets more and more food. And you can see that the trainers, they are really changing dynamically the environment, but the chicken keep learning and the chicken keep understanding that pecking the purple circle, the pink circle, sorry, you can get food yet. Now, could we translate that into algorithms? Of course we can. So we have the layer of the traditional machine learning models that they work, pretty well, but somehow they are static. So whenever we have an economic shift, we may face challenges into how fast can we update a model in order to react to the environment. So what we are proposing as a brand new word, actually, it's the reinforcement learning. So your algorithm, that it's now called agent, it's going to interact with the environment. So you have an initial state, so the initial set of rules that they have been set, the algorithm makes a decision in the way that we use it to do. However, based on the reaction of the environment for this decision, the algorithm would be rewarded. And that reward could be positive or could be negative. And then it will adapt. Well, if I'm getting a positive reward, it means that I'm following the right path, the right direction. So I will be taking exactly the same kind of actions, the same kind of decisions. If I get negative rewards, so it means that the environment is reacting in a different way, and then I should adapt myself. That is the key concept of the reinforcement learning. And let me be a little bit more specific. There is a use case around the debt collections with reinforcement learning. And actually, this one, it's really beautiful. So we have, as a baseline comparison, some figures for a random selection strategy. So you can see that there is a specific amount of money that was recovered randomly. If we apply traditional risk ranking strategies for collection, of course, we are going to beat the random strategy. However, we can almost triple that recovered money if we apply techniques like reinforcement learning over that. So you can see that we get really, a beautiful number, a beautiful increase out of the utilization of this new kind of technology. So it means that our capability to react very quick to the environment responses, they really produce outstanding outcomes. How can we close then the loop? How can we prepare the ground in order to get all the 4 challenges done and then think about that reinforcement learning future? Well, we need to have efficient decision based in analytics insights. So we have a way where we can build the best kind of models. And then we have the power curve component for the decisioning piece. All them together make part of what we are calling power curve analytics. So the best model that we have developed into the platform can be tested and set into production on the power curve side. Then the live production data could be eventually sent back to the environment, and then we restart the learning, the validation, the monitoring process, and then we can get into that dynamic learning pieces. So we have, just to reinforce, the data access and the storage for whatever kind of data that we are talking about. So it could be internal historical data, it could be external data, especially the new ones coming from the transactional environment. We can think about web data for SMEs. Whenever the bureau data is available, this is also an option. Then we have the digital decisioning. We have the power curve component that can be integrated, and then we get into the full automation in this case. And then there is much more than a single standard. There is a set of rules and a set of experience or previous projects that we have developed that we were able to place in what we call the productivity toolbox. So from the modeling components, for the regulatory components, and for the data itself, we can have high quality model development, we can have accelerated compliance requirements, and we can get better prediction accuracy, all in one single place. And the point is, how this looks like, I mean, there should be a framework, or there are some components that we need to think about. Of course, there are several stakeholders or several users that are going to be benefiting from these services. So essentially, this is a cloud-based service where at some point we are going to have the modeling component, where we are going to have the data scientist or the data analyst, the data modeler, independent of the job title that we're going to have, where they're going to create the data insights and the models around the explainability, the machine learning, the reports, and the regulatory components. Then we go through the decision-making process, where we process and monitor the strategy, and then we can get that insights turning into business decisions in this case. And then when it's finally into production, we have, the possibility to offer the best customer experience possible, benefiting from all that environment in one single place in the cloud. This is the power of an integrated analytics and decision-making environment. So we are speaking about a faster time to market, so we can really react very quickly to changes that we can have into the environment. We can have seamless data insights, because whenever we have data being fed back to the platform, we have a level of automation that was never seen before, and then we can really test any kind of changes, even if we cannot yet eventually, for limitations into the regulatory environment, or because yet we need to have some filters that should be human driven. The full automation allows you to quickly get a person to evaluate the outcomes of the model, even if you cannot go 100% data driven, because there is still some humans component depending on the use cases and the kind of business applications that we have. But we can have this automated, which reduces the human error. And this is what we are trying to look for. And then we have a much easier collaboration, because that environment can be shared among consultants, can be shared inside the different departments of the same company. So we don't have silos anymore. And we have another level of IT independency, because we can be fully driven by data and business analysts. So, and we can save money and time in order to, whenever we need, and then getting data back from IT. And also we know that this can take several weeks, if not months, depending on the situation. Something that I really want to highlight, it's into the modeling toolbox. You can find every single step of the process. So the data integration, the data analysis components, the modeling and the validation, the explainability, the possibility to export the models, reporting, governance, and the documentation. You go a step further, you get into the decision making. So everything that has been developed can be exported into Power Curve. So you can have the model import, you can test and validate, adapt the decision strategies, you can run simulations and test. And then if you can really, if you need, go back to the modeling component, make some fine tuning, some adjustments into the model, get back into the test and validation and the simulation of the strategy before getting into fully into deployment. So you keep going to and processing the monitoring, the governance, and again the documentation, until you get exactly to the full point of the production environment. And then that machine learning model integration, remember, it's something that we can get the explainability of whatever actions that the model is taking from whatever attribute that it's based in there. And then this makes us really, I mean, in a powerful way, to, once we are there into the production component that I was mentioning, we can retrieve those decisions. We can then feed back into the system, and having that argument that I was mentioning about being able to quicker automate the model redevelopment. And we are researching, as I told you, exactly that component of the reinforcement learning. And it's something that it's completely new in the market. Once we have everything set, we close the loop with the Power Curve Decision Store, because we can have established the full feedback of the data into our platform itself. Now, last but not least, we'd like just to retrieve some components around the explainability, because from several feedbacks over the past 10 years that I have been working in this field, this has been maybe the biggest challenge, even bigger than the deployment itself, because you need to make reasonable explanation on the decisions you are having out of machine learning models. Now, there are some prerequisites for an efficient machine learning integration. So you can have several steps in order to get it there, and they are going to be fully automated. So you have the integrated machine learning models. So instead of just a recoding, you can get the PMML formats of your model from different sources, like a Python, R, H2O, TensorFlow. It doesn't matter from where the data science has been working on. We can get in that make into production. We can ensure the local explainability, that it's that component for every single decision be able to be explained on a level of an attribute, and then have the integrated model execution, and finally into the production. So into the PCSM, because you can have a fast ingestion of the models, you can get that explainability values in a much easier way, closing the full loop. And this is quite easy to do. So once you are inside the environment, you can get the PMML and the explainability definition. You're going to have all your characteristics mapped and executed. And then you have the final framework, that it's the visual explanation that I was giving you around the several components that you can already have attached into the Power Curve decision engine to benefit from all these components that I was talking about around the deployment and around the explainability itself. That is all that I would like to share. I really would like to thank you for your time, for your attention, and I really hope that this has been interesting for you in a way that helps to overcome the challenge that we know that they are there. So we are now open for Q&A, and once again, thank you very much.
Thank you so much, Leandro, for a very insightful presentation. So we have had some questions coming in. So I would like to start with the first one here. So how quick is it to set up such an environment?
Well, you can, that's always a trick, but a very good question. So we need to understand the steps, right? So those 4 challenges that I was talking about, there is the development, there is the deployment, the explainability, and the monitoring itself. So you can have in a matter of weeks the full environment set to be able to quickly develop the models, depending on the use case that you're going to have. So I thought about weeks, not months. So it's to set up something that it's ready for you to use. The model itself, well, it depends. We have, depending on the kind of use case, you may take, I don't know, 30 days, 40 days to develop a machine learning model. With the automated frameworks that we have implemented, you can have a model completed in a matter of a couple of days, including all the data preparation and the attributes creation that we know that sometimes it's the largest portion of a modeling development process. So we reduce from weeks to days in this case. And then to get the model being able to be simulated and then tested, you just need to export the file out of the Ascent platform and get into Power Curve. And this can be done with a few clicks, and it's something that it's done by the analyst in a matter of minutes, depending, of course, the complexity of the model and the mapping process that they need to get through. But see, here we are always speaking in a very reduced amount of time when compared before. Of course, this needs to be tested, this needs to be simulated, so there will be a dependency on the use case, but the overall process from development to deployment can be now done in a matter of weeks.
Great, thank you, Leandro. And you also mentioned something about, regulations. There's always new regulations to overcome and also a lot of existing ones. So how do you make sure as a company to comply machine learning models with the existing regulations that we see now?
Mm-hmm. No, yeah, absolutely. So we have a specialized team in Experian, the regulatory and advisory team that follows very closely whenever we have any change into the regulatory scenario. So because of the expertise of these consultants, we are always in touch to understand whenever we have any changes, how they are going to be accepted, not just coming out of the regulations, but also for the market itself, how they need to comply. And then we get our modules automated in order to be really responsive to any changes that we have into the regulations. This is one point. The second point is regarding the clarity that we have now to explain the machine learning models. So as one of the charts that I was able to share during the presentation, you can get the complex machine learning models like traditional scorecards. Every single attribute with a specific weight of contribution to the final score. With that, you can have the reports as we use it to have for the traditional models, and this could be used to validate the models themselves and be able to comply with the regulation, especially when we are talking about risk environment. If there are other applications like marketing, fraud detection, these kind of use cases, we know that we have less pressure around this area, but specifically about application scores and for credit risk, we know this can be very tricky. There are several components to comply, but those kind of reports, they are going to help you exactly to follow the regulation. And I'm here speaking about machine learning models specifically, but even the traditional ones, they for sure can be adapted into this framework. So the benefit here, it's the level of automation that you get. So the traditional way of explaining the models, producing the reports, and doing the monitoring according to the regulation are now fully templatized, fully automated with less human interaction. So you can get such kind of reports and monitoring in no time.
Great. So then the big questions that we received. So what are the actual benefits, the return on investment of implementing such solution as you presented today, Leandro?
Yeah. Well, again, this depends on the kind of applications and the use cases, but the biggest one that I can spot on, it's about the faster time to value. And besides this being a kind of a key word, this is actually true. So we had several clients that they came out of an environment where they had from 3 to 6 months to get a model deployed. And this costs, lots of money because there are several stakeholders involved. Now, this model deployment can be down to a matter of weeks, to 3 to 4 weeks. This makes a huge difference because we are speaking not about half a year to deploy a model, we are speaking about weeks. This depends on the use case, but you can see that at least just in efficiency, just in costs, we are improving it by 50%. If you get a better model out of it as well, because you're using different techniques, depending on the average ticket that you have on your use case, we can easily speak here about some million of euros around the year as ROI for that investment itself, plus the time that you save, that you get in order, to get those components ready for production much quicker. So this is, in a high level, but actually giving you some actual figures, it's how fast you can get those results for your company.
Great. Thanks a lot, Leandro. I can't see that we have received any more questions, so I think we'll just then give everybody some time back. If you have any questions after this presentation, please do not hesitate to reach out and we will get back to you. So I just want to thank you, Leandro, for a great presentation and for everyone for attending today. And I wish you all a great day.
Thank you very much, Charlotte. Thank you very much, everybody. Have a great day. Bye-bye.
Thank you. Bye-bye.